What the heck is a step function? Have you ever run into a problem that asks you to work with one of these before? They're not super common, so they don't come up very often, but they're not too complicated. So in this video, I'm going to show you exactly what a step function is, and we're going to work through an example that requires understanding what a step function is and what it's really telling you. Specifically, we're going to be given some step function and we're going to evaluate that function at specific values. And I'm going to show you exactly how to do it every step of the way. So let's go ahead and jump right into the problem and I'll show you what I'm talking about. We're going to evaluate the function for the indicated values. So we're going to evaluate g of 1/8, g of 9, g of -4, and g of 3/2. All right, sorry about that. So we have a 4-part problem here. We're going to evaluate this function at these 4 different values. But before we get into how to do that, I want to take a kind of a step back and think about what this function is. G of x equals -7 times basically this step function component of this equation, where what's in the step function part is x plus 4 and then plus 6 after all that. So what does this mean, these little brackets here? This is what is called a step function when you have these brackets like this. Basically, the reason why it's called that is what it means is you're taking the lowest integer that is equal to or less than whatever is inside the brackets here. So another way to think of it, if you have ever taken any like computer science classes, this is kind of like taking the floor of whatever's in here. That's another kind of terminology that basically means the same thing. You're just taking the integer that is directly beneath whatever this is. So essentially think of it as rounding down to the nearest whole number. So whenever whatever is in here is a positive number, you're just rounding down. You're just dropping whatever's at the decimal or, other than the whole number integer that you have there. If this is a negative number, like let's say you're taking the step of -5.5, it's going to round down to -6. So the nearest integer that is less than or equal to -5.5 would be -6. If you have a positive number though, it's basically just going to drop the decimal. So the step of +5.5 is going to be +5. So that's basically what this kind of double bracket means and what it does. So when we're evaluating these 4 different things, really just like any other function, when you're trying to take g of 1/8, for example, all that means is go to your function g of x right here. Wherever you see an x, just replace that x with whatever number is in the parentheses here. So we're just going to replace our x with 1/8 to find g of 1/8. So that would be -7 times the step of 1/8 plus 4, and then close that step function part and then add 6. So basically this is kind of the unsimplified version of what g of 1/8 means. You're just going to your function g, replacing any x you see with whatever numbers in the parentheses there, in this case 1/8. So let's go ahead and think about how to actually evaluate this now. 1/8 plus 4 would be 4 and 1/8. Since we're taking the step of 4 and 1/8, that's just going to be 4. We're just going to take the integer, the whole number that is directly beneath 4 and 1/8. So essentially it just kind of drops off that mixed number fraction part of it. So that would just be 4 times -7 plus 6. -7 times 4 would be -28, plus 6 would be -22. So g of 1/8 will be -22. Okay. So next we are going to evaluate g of 9. So again, we're just going to go to our function g. Wherever we see an x, we're going to replace it with 9. So doing that is going to give us -7 times the step of 9 plus 4 plus 6. 9 plus 4 is 13. And then taking the step of an integer whole number isn't really going to change it, right? Because the integer that is less than or equal to, and closest to whatever you're taking the step of, is just the integer, right? 13 is less than or equal to 13 and is an integer. So that's really all that's going to be. So that'll be 13 times negative 7 plus 6. Negative 7 times 13 would be negative 91, I believe. 7 times 10 is 70, plus 21 would be 91. Yeah, so negative 91 plus 6. Negative 91 plus 6 would simplify to negative 85. So that's going to be g of 9. And then for g of negative 4, we're going to have negative 7. Again, we're just going into here, replacing the x with whatever's in the parentheses, times the step of negative 4 plus 4, plus 6. Negative 4 plus 4 is 0. Since 0 is an integer, taking the step of 0 also does not change it. This step function is not going to have any impact whenever you have a whole number or an integer. An integer is just a whole number. Whenever you're taking the step of a whole number, it's not going to change it. So the step of 0 is 0. 7 times 0, or negative 7 times 0 is 0, plus 6 is 6. So that's going to be g of negative 4. And let's go on to g of 3/2 now. So that'll be, again, just going to here, replacing our x with whatever's in the parentheses here. We're going to get negative 7 times the step of 3/2 plus 4 plus 6. Okay, so now 3/2 plus 4, let's kind of just draw that off to the side here. 3/2 plus 4, whenever you're adding fractions, you always want to get a like denominator. So we want to get a like denominator of 2 here. So we would want to multiply 4 by 2 over 2, because multiplying something by the same number divided by the same number is just multiplying it by 1, which doesn't change its value. So 4 times 2 over 2 would be 8 over 2 plus 3 over 2. Now that they have the same denominator, we can just add their numerators. 3 plus 8 is 11 over 2. So we're going to have the step of 11 over 2 times negative 7 plus 6. 11 over 2 is the same as 5.5, so 5.5. I coincidentally kind of gave that as an example over here. Since taking the step of 5.5 is just rounding it down to the nearest whole number, the step of 11 over 2 is just 5. So we're going to have 5 times negative 7 plus 6. Negative 7 times 5 would be negative 35. Plus 6 is going to give us negative 29. So negative 29 will be g of 3/2. Now, I'm sure step functions make a little bit more sense to you, but there's one more thing I want you to make sure to go learn about real quick. And that is the type of problem where we have to go in the opposite order. Instead of evaluating a given function at specific values, what if you need to create a function that fits specific evaluated points that you're given? Fortunately, I actually just made a video about this. Just go click on that video right there. I'll show you an example exactly how to do a problem like that. And by the end of that video, you should be feeling a lot better about both step functions and linear functions as well.